Hi friends, welcome to Unit 4, Day 4 notes. Example 4, solving exponential equations. Again, the steps to solve are over here on the left-hand side. What we're going to do is solve the following exponential equations and checking again for extraneous solutions. We're going to try and see if we can get these to have the same base. 9 is very close to that 3. In fact, if I take 3 squared, I'm going to get 9. And that's actually the way you want to go with this. Is you want to get so that you have the same base that's the lowest possible base from that group. Now, because 3 squared, I'm going to put a set of parentheses around that 2x plus 4 because I do need to distribute that 2 to both of those. So that gives me 3 to the 4x plus 8. Now, because I have the same base, I can use my property that we've talked about previously and setting both of these equal to each other. The reason I'm doing that is I'm actually applying a logarithm base 3 on both sides. So that allows me to say that x is equal to 4x plus 8. Let's get everything over. So I'm going to have minus 8 minus 8. So I have negative 8 equals 3x, divide by 3, divide by 3. And I get x equals negative 8 thirds. So now, again, checking this to make sure this works. So I have 3 to the negative 8 thirds. And I'm saying that that's equal to 9 to the 2 times negative 8 thirds plus 4. And those are equivalent. And so this tells me that this is a solution. A lot of students want to jump into, from the previous section where we talked about having the domain be a negative number. With exponentials, you remember you can raise an exponent to a negative number. That is perfectly fine. 26. Now a lot of students will get confused because there's not a way to make these have the same common bases. So what do you do in this point? Well, in this case, what you want to do, if you ever have a situation where you can't hit, or you can't get both bases to be the same, is that you hit both sides with a log. So I'm going to take both sides, log base 10. We'll talk about a different way to approach this here shortly, of 8 to the x equals log base 10 of 21. And now what I can do is I can pull out x in front. So this is x times log, again using my power property, x times log 8 equals log of 21. And then you can divide by log of 8 on both sides. So you get x equals log of 21 over log of 8. Now, again, a lot of students kind of say, okay, is there a different way to approach this? Because I hint that that log base 10 is not the same, and that's because this is equivalent to log base 8 of 21. Now remember, I said you could hit, you could take the log of whatever base you want on both sides. It doesn't have to be log base 10. So by choosing log base 8 of log base 8 instead, you actually simplify this in a very easy step, and you're done with the problem because there's no simplification at that point. Again, I verified this in the other video. You should verify that this is in fact true and the same, and that log base 8 of 21 is the same as log of 21 divided by log of 8. We're going to have to do something similar with this as well. So here we have log of 5. So log 5, 2x minus 3 equals log of 8, the x plus 1. So this is going to be 2x minus 3 in parentheses times log of 5 equals x plus 1 in parentheses times log of 8. Now, a lot of students get confused on what to do here because, again, we want to end up with not dividing by an x. So a lot of students get confused. Remember, log of 5 and log of 8, these are numbers. These are values. We can actually distribute these to both of these. So I can distribute So this gives me 2x times log of 5 minus 3 times log of 5. And then that's equal to x log 8 plus log 8. Now I can get everything that has a variable to the same side. So minus x times log of 8 on both sides. I'm going to add 3 log of 5. So this gives me 2x times log of 5 minus x log of 8 equals 3 log 5 plus log of 8. Now, because these have the same bases, we can combine them. So here, I can actually factor out, let's factor out an x from both of these first. So that gives me x times 2 times log of 5 minus log of 8 equals, everything over here is still the same, log of 5 plus log of 8. And then now we can divide by 2 times log of 5 minus log of 8 off both sides. And I'm left with x equals 3 times log of 5 plus log of 8 divided by 2 times log of 5 minus log of 8. This is sufficient for as far as we need to go for now. We're going to talk about other ways to simplify this later. Here we have e, and then this says the absolute value of x equals 50. Again, e, natural log, so we're going to take the natural log on both sides. So natural log of e to the absolute value of x equals the natural log of 50. Bring this down, so I have the absolute value of x times the natural log of e equals the natural log of 50. The natural log of e is just 1, so this is the absolute value of x equals natural log of 50. So I get x equals plus and minus the natural log of 50. Remember, whenever you plug in negative natural log of 50 in for x, you're going to simplify it by taking the absolute value of it first and then applying the rest. And remember, the negative sign here is in front of the natural log, not of the 50. If it was of the 50, we would need to do something else. I forgot to box that answer. I apologize. Yeah, okay, 29, looking at my time. These have the same bases. When you have the same base, you can add the exponents. So this is e to the 4x plus x minus 1 equals 5 times e. 4x, I believe this is written incorrectly. I think this is supposed to be e to the 5th instead. Yeah, go ahead and change this to e to the 5th if it's not already shown. And then simplifying this, we have e to the 5x minus 1 equals e to the 5th. And then remember, take the natural log of both sides. And then what we end up with is 5x minus 1 equals 5. Add 1. 5x equals 6. 5 by 5, we get x equals 6/5. And then again, verify that is in fact the answer. For time's sake, I am going to skip down. Now let's set up 30, and then we'll skip to the rest for in class. This looks like e squared minus 6. Wait a second. This looks like a quadratic, except we need to use u substitution. So we're going to set u equal to e to the x. And by doing that, then we have, let's see, we have u squared here minus 6u plus 5 equals 0, and then we can solve from there. So we will finish out the rest of these remaining one in class as well, and then talk about the example problem with solving for specific variables using logarithmic and exponential functions in class as well. I hope you have a wonderful day. I will see you later.